All right, kiddos, this is it. Last one of the semester. Assignment 17, polynomial graphs, day 2. So I told you that this was a little bit of a hodgepodge of graphing polynomials. This is day 2. So let's see. Oh, good. We do have some. Okay. So we are going to match an equation to its graph using the roots. And we're going to talk about something that we talked about in lesson 16 here again. Determine increasing, decreasing intervals and positive or negative integrals when we are given a graph. We're going to write end behavior if we're given a graph, end behavior if we're given a function. And then the last one kind of puts it all together and determines some features of polynomial graphs. So remember we started out lesson 16 talking about the solutions or the roots of an equation. And those were the x-intercepts. Right? So we have one here at -2. We have one here at 1. And our last one is at 8. So if we go way back to when we were talking about quadratics, and one of the ways to solve quadratics was to factor it. So you had things, this is unrelated to this particular problem. Maybe you factored and got x minus 2 and x plus 4. And then we found the zeros. So we figured out what made each of those equal to 0. And we got +2 because 2 minus 2 is 0, and -4
probably do
because
an ice cold
-4
shower,
plus
I never
4 is 0.
really being dirty is like, what's even the point?
So given these roots, we kind of want to work backwards now. We're given the roots here and we want to write the factors because that's what's going to allow us to match. So if -2 is a root, then the factor, I should have given us more room here. The factor is x plus 2 because if I put -2 in there, -2 plus 2 would give me 0. If +1 is a root, I need to write a factor. So I need to write something that looks like this so that if I put 1 in, it will equal 0. So it would have to be x minus 1. So if I put a 1 in for the x, 1 minus 1 would give me 0. And then for the 8, it would be x minus 8. So this right here is a factored form of an equation that would give you this. If you put this into Desmos, into the graphing feature on Desmos, you would get this. Although we're kind of ignoring the fact that there could be a number in front. We're kind of skipping over that for this week. So one of the sections in your delta, you're just matching which one of these could represent the graph shown. So remember on lesson 16, I said that if it hits, so here's our 0 right here at +3, right? If we write that as a factor, that's x minus 3. But remember I told you that if it hits and bounces back off, that's called a bounce. And that means that that number is a solution twice. So that means that x minus 3 is a factor 2 times, which would mean our answer is D right here. X minus 3 and then x minus 3 again. Having 2 of them is what creates that bounce right there. So let's do the second one. There's a 0 right here at 2. And there's a 0 right here at 7. Okay, so can we write the factors for those? If +2 is a 0, then the factor is x minus 2, because I need to put 2 in there. 2 minus 2, that does give me 0. Because it bounces, it doesn't go straight across, like the 7 goes straight across. This one hits and bounces off. That means it is a root twice. So I need to write it twice. And then there's a root at 7. So if the root's at 7 and we want to write the factor, it would be the opposite, x minus 7. And they don't have to be in this order. They can be in any order. Notice I have my x minus 7 at the end. Some are in front. Oh, these are all in front. So it doesn't matter which order you put them in. It just pay attention to the signs. So I want it to be minus 2, minus 2, minus 7. That would be B right here. Okay. The next section, increasing, decreasing, and positive, negative. This one tends to be really challenging for people. I think part of it may have to do with how we write the answers. We shall see. Okay, so the first one is increasing or decreasing. So a graph is increasing if, as you go from left to right, it's going up. So we're traveling always left to right. So if we start on the farthest most left side, the graph is going down, right? As I go to the right, I'm going down, I'm going down, I'm going down, I'm going down, I'm going down. When I get to A, it turns and it starts going up. So I'm going to color code this graph. It is increasing right here from A to B. It's going up, going up, going up, going up. So that's increasing. Now it starts going down. So now it's decreasing. We'll get to the color coding that in a second. Going down, 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 down. Now I hit, and now it starts going up, right? Once I hit D from left to right, now I'm walking up. So think about walking. Now I'm walking uphill, 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 uphill. It kind of flattens out, right? But I'm still going uphill, 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 uphill. All right, so it is increasing where it's pink and pink. Okay, so now decreasing. Decreasing means you're walking downhill. From left to right, you are going downhill. So starting at the left side, I'm walking downhill, 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 right? Now we already said this was increasing. Now I'm walking uphill. Then I get to the top of the hill, downhill, 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 downhill. So the blues, I'm walking downhill, I'm decreasing, and the pinks are walking uphill, I'm increasing. Okay. The second part, positive and negative. These have to do with where you are on, or where the graph lies. It is positive everywhere the graph is above the x-axis. So I'm sitting here, like you guys can't see me, I'm sitting here putting my hand across the x-axis like this. If I had a little, I wish it would let me draw a shape. If I had a little box, I would cover it up, but I don't have that. Okay, so if I had a little box, I would cover up the whole bottom half of the screen down here and say, ignore that. It is positive where it's above the x-axis. So it's positive here, still positive. I'm still above, still positive, still positive. Oh, now I'm going to dip down under. Okay, oh, here we go. Here, this is above the x-axis, so it's positive. It is negative anywhere it's below the x-axis. So where on this is our graph below the x-axis? All down here. It's below. So you need to be able to kind of differentiate because they're similar, right? They're two are similar, but you need to be able to differentiate the difference between increasing, decreasing, and positive and negative. So maybe keep this chart, and if you did any color coding, keep that handy. They're going to mix the two together in the problems. So they're going to give you problems like this. And, I'm so sorry. You're not going to have to write it anything crazy. They're going to ask you very specific problems. So the function is graph below. What's true about the graph on the interval from point D to point E? We need to answer like both. Right? We need to say if it's increasing or decreasing and if it's positive or negative. So D to E is this little bit down here. Just that little part. So if I'm walking, right, I'm walking uphill. So I'm increasing. But I'm below the x-axis. Like I'm still think of it as underwater. I'm underground, right? I'm going up, but I'm still under the x-axis. So I'm still negative. Let's look at the next one. This one says, what is true about the graph on the interval from -infinity to a? Oh, I picked two samples that are the same. So when x equals -infinity, that means all the way over here on the left until I get to a. So from this arrow until I get to a, what's happening? Probably should have picked a different example because again, I'm going up, right? I'm swimming up. If we're talking about like looking at it, this is water level. I'm going up, up, up. So I'm increasing, but I'm still below the x-axis. I'm below the surface. So I'm still negative. Let's pick another one to do here so that we can do a different one. What about from, what about, I don't know. Should we do e to f? How about e to f? So here's e and here's f. So I'm walking, I'm going left to right. What am I doing? I'm going down. So I'm decreasing. And I am below the x-axis. I'm below the surface. So negative. Can you find a place where I am decreasing and positive? Where am I decreasing? Positive. There are two places on that graph where I am decreasing and positive. Right here I am. From B to C, I am decreasing but positive, or sorry, B to C. And then from D to E, I am decreasing and positive as well. And our last little bit is end behavior. So we need to look at end behavior when we are given equations. And we also need to talk about end behavior when we are given graphs. And the toughest part of end behavior, really, frankly, is understanding the notation. Lucky for you, these are all multiple choice, so that makes your life much easier. We already talked about equations being odd or even, right? And if they're odd, then the two ends go in opposite directions, like these two are odd. And if they're even, then they go in the same direction. These two are even. So this one is odd. And the other part that you need to look at is if the leading coefficient, if that first term is positive or negative. Positive, it would point upward. So this is odd and positive for the first leading coefficient. This one is also odd because the two ends are going in opposite directions, but since the right-hand side is pointing down, that is negative. So the notation, I'm going to thoroughly explain one or two, and then the other ones I might fill in a little more quickly. As x approaches -infinity, so x is left and right. Here's the x-axis. Negative is the left. So this is saying the left-hand side of the graph, which direction is it pointing? It is pointing down. Down is negative. All your answers are just infinity or negative infinity. That's it. There's no numbers or anything like that. As x is left and right on the graph. So as x goes to the positive, that means the right-hand side of the graph. As x goes positive, the right-hand side of the graph. Which way is the graph pointing? It is pointing up. Up is positive. Okay, so let's look at this next one. If the degree is odd and negative, what happens on the left side of the graph? So as x goes to the negative or left-hand side, which way is it pointing? It is pointing up. Up is positive. As x goes to the positive side, that means the right-hand side of the graph. So the right-hand side of the graph, which way is it pointing? It is pointing down. Down is negative. So you're going to be able to, if you fill this chart in carefully, use this chart to answer all of the rest of these problems. Okay, these two, since both of the ends are going in the same direction, right? They're both going up. These are both going down. These are both even functions. This one is also even. On this one, the right-hand side points up, so it is positive. On this side, the right-hand side points down, so it is, negative. And when we do this, we're talking about, if you put it in standard form, the first term. The degree would be even, the coefficient would be negative. Okay? So as x goes negative, that's the left. Which direction is the graph point? It points up. Up is positive. As x goes to the positive side, that means the right-hand side. Which way does the graph point on the right-hand side? Up. Up is positive. This one, as x goes to the left, the graph is going down, so negative infinity. As x goes to the right, so the right-hand side of the graph, which way is it pointing? It is pointing down. Down is negative infinity. So you're going to use this chart to answer our questions. But first, just like so many other times, you need to put it in standard form. You really actually only care about the first term, but we'll write it in standard form. 7x cubed minus 84x squared plus 146x, 7x. $147x plus 686. All I care about is the first term. Okay? The coefficient, the degree, is odd. So not the coefficient. The degree is odd. The coefficient is positive. The degree comes from the exponent. The positive or negative is based on the coefficient. I don't care that 7 is odd. That has nothing to do with it. I only care that 7 is positive and the exponent is odd. So if you look back up at your graph or your chart that we just made, odd, positive. Here's odd, positive. Is this first box up here. So look at these. Look at these. I got some typos. Hold. Oh, no, I don't hear there. Okay, so as x goes to negative, y should go to negative. As x goes to negative, y goes to positive. That doesn't work. As x goes to negative, y goes to positive. Nope, that doesn't work. That doesn't work. That doesn't work. As x goes to negative, y goes to positive. Okay, maybe that. X goes to negative, y goes to negative. Okay, maybe that. So let's look at the other one, the other side of the graph. As x goes to the positive infinity, y also goes to positive infinity. So as x goes to positive infinity, this one says y goes to negative. Nope, that doesn't work. So here it is. You just have to really pay attention. Remember, f of x is like y, right? That should be old news. F of x is the same as your y. So you just have to really pay attention to the positives and negatives because they're all x arrow infinity and y arrow infinity. The only difference is the positives and negatives. So you just got to be careful. Okay, let's try. You want to try? Why don't you pause me and try B? Okay. So did you write it in standard form? Oh. I tried and failed. Okay, there it is in standard form. All I care about is the first term. That is it. That's all that matters to me. It is an even degree, and the coefficient tells me that it is negative because the 2 is negative. I don't care if 2 is positive or is even or odd, only that it is negative. So I look back up at my chart, even and negative. That's this one right here. So as x goes to negative, y goes to negative. That's these bottom two. As x goes to positive infinity, y goes to negative. So as x goes positive, y goes negative. So it's the third one. Now we're going to do the same thing, except based on the graph. Okay. Oh, God. Man, every time I put it into Cami, it gets funky. Look at, like it cut some of it off. It cut the fourth choices off. I was so careful. I also was so careful to reformat so these infinities all fit, and now they don't. Okay, so the left-hand side points down, and the right-hand side points down. So as x goes to positive, that means the right-hand side, as x goes to positive, your graph is going down. That doesn't go down, that goes to up, because that's positive. As x goes to the right, f of x goes negative. It goes down. Okay, that one's good. As x goes to the negative, so the left-hand side, f of x goes positive, means it goes up. Nope, that doesn't work. They both point down. So both of your y's should go to negative infinity because both sides are pointing down. Yes, it's this one. Got to check that last one for a second. Or you can look back up if that's, you're like, what in the heck? Look back up. We don't care about any of the middle of the graph. Both of these ends point down. So look back up here at the one where both of the ends point down. And you can use that chart right there. So like for this one, I don't care about any of this middle stuff. All I care is that the two ends, which way the two ends point. So the left goes down and the right goes up. Come back up to the chart and match which of those the left goes down and the right goes up. That's this one, right? Odd and positive. So you can match this with the multiple choice. X negative, negative, and then positive, positive. So X is negative, negative. Nope, not that one. Okay, so it's this one down here. X is negative, Y is negative, X is positive, and positive. Right? Because we just care about the signs. Positive infinity goes with positive infinity, negative infinity goes with negative infinity, because that's what the chart showed us. Okay, the last type of example, determine features of polynomial graphs. This one's just going to have like, it has a couple of drop-down menus. So I just did underlined where you would circle them for the notes. And then it has a couple of fill in the boxes. So you have a polynomial graph shown below. Fill in the form regarding the features of this graph. The degree of the polynomial. So the degree tells you that the ends go in either the same direction or the opposite. Since they both go in the same direction, since the both ends go in the same direction, that tells you that the degree is even. Because they point down, right? The right-hand side points down. The right side points down. That tells you that the leading coefficient is negative. It all looks on the right-hand side. If it points down, the leading coefficient's negative. If it points up, the leading coefficient's positive. There are how many real roots? Roots are x-intercepts. So how many x-intercepts are there? 1, 2, 3. And how many minimum values? So minimum happens at the bottom of like a valley. There is one minimum right here. Okay, why don't you pause me for one last example and see how you do on this one. So this polynomial, again, both ends, I chose another one where they both point down. So same direction. Means that it is even. And because the right side points down, it is negative. The leading coefficient is negative. How many roots are there? I see 1, 2, 3, 4, 5 roots. And how many maximums? Maximums come at the top of peaks or hills. So there's one maximum. There's another one. And that little tiny one is a third one. So there are 3 relative maximums.